Greetings and welcome to my new calculus channel. My name is John Gabriel, and so today I'm going to talk a little bit more about the great embarrassment of the mainstream, and I'm going to refer to a very popular calculus teacher called Eddie Wu. He's actually a complete dimwit, but that's besides the point. He's got a huge following, and obviously his followers don't know any better. So without further ado, let's begin. Now, you'll recall that in the previous video I showed you where I talked about Norman Wildberger and his video in the series of how he believed that calculus had to be rigorized. Well, so what we have here now is Eddie Wu, and I'm going to just introduce you to what he says in this video and then show you why it is pretty embarrassing. Okay, so let's hear what he says.
One last thing, what difference does that make? If it weren't there, that limit as h approaches 0, if it weren't there, it's not meaningless, but what would it be? It'd be something else. Yeah. It'd be the gradient of not the tangent. The tangent's what we want, right? But if you've got 2 points that are actually apart, it'll be the secant, won't it? Right? It's not meaningless.
Okay, so what Eddie Wu here is trying to tell you is that you actually need that little thing that he circled on the side there. Okay, so first of all, it's true that the finite difference quotient, this finite difference quotient, which we write down like this, is in fact the secant line tangent. Okay, it's true, and in fact this is equal to f prime of x only in one case, when f is a straight line. Okay, so that's the only time it's equal to f prime of x. But now so he goes about and says that, I don't know why this is happening again. Let me just close that. Okay, so he says that f prime of x is equal to the limit as h approaches 0, and he circled it like this. Now you don't actually need this. This is garbage, because, and I'll tell you why you don't need it, because f of x, f prime of x, is in fact equal to f of x plus h minus f of x all over h minus q x comma h. Okay, so the great embarrassment of mainstream mathematics is that they never realized this here is actually the difference in the tangent line quotient, and that you can basically simply calculate this finite difference and discard all the terms in h. Okay, so it's as simple as that. So if you had for example x squared, or f of x is equal to f squared, like that, then you would simply say, okay, well, f prime of x is equal, according to this method, is equal to 2x plus h, but it's not actually equal to this, is it? We have to discard the h's, and then it's equal, right? So essentially taking the limit as h goes to 0 is in fact setting h equal to 0. No matter how much mainstream moronic academics love to deny this, this is exactly equivalent to what they do when they say take the limit as h goes to 0. It's as simple as that. So they've been pulling the wool over your eyes for many decades, and I'm revealing this stuff to you because I want to open your eyes. And of course, the identity that you see here is my geometric historic identity, which has been proved in a file which I shall place in the details section, in the comment section, all right, of my video. Also, I have shown how you can define your definite integral in terms of this very same identity. Okay, and of course this isn't the new calculus, by the way. This idea was taken from the new calculus, but it's not the new calculus, and never was. The new calculus is 100% rigorous. This isn't, because it allows tangent lines at points of inflection. The new calculus does not, and it's not a problem, because the mean value theorem, which is the fundamental theorem of calculus, does not care about inflection points. So that's pretty much it. I don't want to ramble on and on. If you're not already a subscriber, become one. Tell your friends about it, and please contribute to my GoFundMe page, my GoFundMe site. I could definitely use the cash. So that's pretty much it for now. My name is John.